Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Hope all of you are fine by the mercy of Almighty Allah. I'm Irene Parvin. Welcome once again to our online chemistry first paper class, English version, arranged by KPB School and College. Today, I'm going to discuss polarization of ions, that is covalent character of ionic compounds and hydrogen bond under chapter 3. The title of chapter 3 is periodic properties of elements and chemical bonds. At first, I would like to discuss polarization of ions. Due to the electron cloud attraction by the cation and its repulsion of an ionic nucleus, the shape of the anion is changed and its electron cloud is somewhat shifted towards the cation. This is called deformation or polarization of the anion by the cation. That is, polarization is occurred by the cation. And here some what is very important: attraction by the cation and its repulsion of an ionic nucleus and shape of anion is changed, and thus electron clouds shifted towards the cation and deformation or polarization is occurred. For example, in the figure, A is an cation and B is an anion, and both of them are spherical shape. When they come closer, the positive charge of cation, that is A plus, and uh, A plus ion attracts the negative electron cloud of the anion, that is B minus, towards itself. That is, cation A plus attracts the electron cloud of the anion towards itself. At the same time, it repels the nucleus of the anion. Then the shape of the anion is changed and polarization of ions occur. Look here, before attraction, the shape of the both ion is spherical, and after attraction the shape of anion is changed and thus polarization is occurred. Now I would like to discuss covalent character of ionic compounds and Fazan's rule. At first, what is covalent character? Due to the polarization in the molecule of ionic compounds, the concentration of electrons become high in the middle of the two nuclei that I have discussed before slide. As a result, both the atom can share the electron equally and show the characteristics of covalent bond. This is called covalent character of ionic compounds, and polarization occurs between ionic compounds. And due to the polarization of ionic compound, Fazan gave some rules. These rules are known as Fazan's rule. The greatest effect of polarization is produced in molecules having: number 1, smaller size of cation; 2. Larger size of anion. 3. High charge in cation and anion. Number 5. Cations with electrons in d or f orbital, and lastly having more than one valency. Now I would like to discuss the first rule of Fazan, smaller size of cation. How uh, how a cation, when its size is small, then it affects the polarization. The polarization capacity increases with the gradual decrease in the size of the cation. I repeat it again, the polarization capacity increase. Polarization capacity increase, that means covalent character increase with the gradual decrease in the size of the cation. For example, look at the figure please. Lithium ion is smaller than sodium cation, and sodium cation is smaller than potassium cation. So polarization is more in lithium than sodium cation, and in the same way polarization of sodium cation is greater than potassium cation. And when lithium form compound lithium chloride, so lithium chloride, covalent character of lithium chloride is greater than sodium chloride, and covalent character of sodium chloride is greater than potassium chloride. Now I would like to discuss another rule, larger size of anion. The polarization capacity increases with the gradual increase in the size of anion. That means polarization increase when increase the size of anion. Because if the size of the anion increases, then the distance between the nucleus of the anion and the outermost level of the anion increases. Moreover, when the size of the anion is large, its electron cloud comes closer to the nucleus of the cation. So the cation easily attracts the electron cloud. Hence polarization will be high. For example, fluoride ion. The size of fluoride ion is smaller than chloride ion, and chloride ion is smaller than bromide ion, and the size of bromide ion is smaller than iodide ion. And when size of anion increase, the covalent character also increase. That means the covalent character of sodium iodide is greater than uh, sodium bromide, and the covalent character of sodium bromide is greater than covalent character of sodium chloride, and the and covalent character of sodium chloride is greater than sodium fluoride. That is, when the size of anion is increased, then polarization is also increases. Now another rules, high charge of cation and anion. If the charge of the anion and cation increases, the polarization also increases because the attraction force between the electron cloud and the nucleus of the another atom increases. For example, in the figure, cation sodium has lowest charge and cation silicon has highest charge. The charge of sodium is 1 plus 1 and the charge of silicon cation is plus 4. So covalent character of silicon tetrachloride is more than aluminum chloride, and covalent character of aluminum chloride is more than calcium chloride, and covalent character of calcium chloride is more than sodium chloride. That is when charge of cation increase, that means covalent character is also increased. Now another rule, cation with electron in d or f orbital. If the electrons are in d or f orbital of the cation, then the polarization will be greater. That means when d or f orbital is present in a cation, then the polarization will be greater because then the size of the cation increase, but attraction between nucleus and outermost energy level increase. As a result, the size of the cation decrease, and that's why polarization increase. For example, the ionic radius of sodium ion is 0.950 degree angstrom. Again, the ionic radius of copper ion is 0.0960 degree angstrom. So the covalent character of copper ion compound is more than sodium ion compound. Now, having more than one valency, the elements which having more than one valency, the compound of that element having highest valency have more covalent character. For example, iron has two variable valency. You know, iron has two variable valency, and that's why iron form iron 2 plus ion and iron 3 plus ion. Here, iron 3 plus ion forms ferric trichloride and iron 2 plus ion forms ferrous chloride. Here in ferric chloride, the valency of iron is used 3, that is highest valency is used in ferric chloride. So covalent character of ferric chloride is more than ferrous chloride. Now I would like to discuss about hydrogen bond. Before discussing hydrogen bond, you have know about electronegativity. Though I have already discussed electronegativity in earlier class, but for your convenience, I am repeating it again. The relative tendency of an atom in a molecule to attract, share, pair of electrons towards itself is termed its electronegativity. Here some word attracted shared pair of electrons towards itself. That means the atom which has tendency to attract shared pair of electrons towards itself is termed as its electronegativity. For example, in HCl molecule, chlorine atom is more chlorine atom is more electronegative than hydrogen atom. That's why the shared pair of electrons are attracted more towards chlorine atom. Now, I would like to discuss hydrogen bond. Earlier, I have already discussed ionic bond, covalent bond, and coordinate bond. And today, I'm going to discuss hydrogen bond. Hydrogen bond is a bond in which hydrogen atom of one molecule is bound to the highly electronegative atom, that is oxygen, nitrogen, fluorine, of another molecule of the same or different substance. It is special type of permanent dipole-dipole interaction. Here some word is also important, and these are hydrogen molecule bound to the highly electronegative atom, and that's why a special type of permanent dipole-dipole interaction is occurred and hydrogen bomb is formed. Dipole-dipole interaction is occurred, and for example, when a hydrogen atom is covalently bonded to highly electronegative atom like fluorine, oxygen, nitrogen, etc. The electron pair forming the bond is partially shifted towards the more electronegative atom. Thus, hydrogen develops a partial positive charge and partial negative charge, and this type of molecule is known as dipole, and one dipole attracts another dipole by opposite end and forming a big molecular cluster. I repeat it again. One dipole attracts another dipole by opposite charge and forming a big molecular cluster. In this cluster, uh, acts like a bridge. Hydrogen in this cluster, hydrogen bond acts like a bridge in between two neighbor dipoles. This type of bridge, which is formed by hydrogen, is known as hydrogen bond. Usually, a hydrogen bond is represented by a dotted line. For example, hydrogen bond of water molecule. Here, uh, in water molecule, hydrogen atom is less electronegative compared to oxygen, and oxygen is more electronegative. That's why a partial positive charge is created on hydrogen end and a partial negative charge is created on oxygen end. And when two water molecules close, they form hydrogen bond between them. Look at the figure, please. This is hydrogen bond and it is represented by dotted line. And one dipole here, one dipole of water molecule, that is here partial negative dipole, attract the another dipole of another water molecule, that is positive dipole of hydrogen of another water molecule. and between them a hydrogen bond is formed and it acts as a bridge, and thus hydrogen bond of water molecule is formed. Now we learn about the influence of hydrogen bonding on the physical properties. Due to hydrogen bonding, compounds gain association, high melting and boiling point, and effect on physical state and solubility. And I discuss them one after another. At first, I would like to discuss about association. Due to intermolecular hydrogen bonding, two or more molecules of a compound exist as associated molecules. For example, ethanoic acid and benzoic acid form dimer due to the presence of hydrogen bond. As a result, molecular mass is seemed to be double. That means due to the formation of hydrogen bond between ethanoic acid, they form dimer and their molecular mass becomes double. This results in the increase in the size as well as in the molecular mass. Now high melting and boiling point. The compounds containing hydrogen bonds have high melting and boiling points. In case of water, hydrogen bond is present. The strong intermolecular hydrogen bonds bind the water molecules. That's why it needs more energy and its boiling point is higher, that is 100 degrees centigrade. Now, effect on physical state. Hydrogen bonding also influences the physical state of the substance, that is solid, liquid, or gas. For example, both oxygen and sulfur belong to the same group, but water is liquid at ordinary temperature, while hydrogen sulfide is a gas. What is the reason? Because in case of water, hydrogen bond is present due to the difference of electronegativity of hydrogen and oxygen. On the other hand, in hydrogen sulfide, no hydrogen bonding is possible because the uh, difference of electronegativity of hydrogen and sulfur is less than 0.3. That's why hydrogen bonding in hydrogen sulfide is impossible. And for this reason, hydrogen sulfide is in gaseous state. And now solubility. Hydrogen bonding also increases the solubility of one substance in another. The covalent compounds which can form hydrogen bonds with water readily dissolves in it. Actually, usually covalent compounds are not soluble in water, but those covalent compounds which form a hydrogen bond, they are soluble in water. For example, ethanol, ammonia, etc. So, from these two topics, there are many important questions that that is actually that is important for your board exam. Now, I'm mentioning some Fazan's rules related questions which you need to know about. At first, number one, how Fazan's rule can explain the covalent nature of aluminum chloride. This question is, you can explain this question by using Fazan's rule. And another one is, why is the melting point of ferrous chloride is more than that of ferric chloride? You can also explain these questions by Fazan's rule. And another one is, why is the melting point of cuprous chloride is less than sodium chloride? And hydrogen bond related question are, why the molecular mass of ethanoic acid is double? Another question is, uh, the melting point and boiling point of water is greater than hydrogen sulfide. Why? And this type of question is very important for your board exam, and these two topics are very important for your upcoming exam. So learn these topics seriously. No more today. Best of luck. Take care. Bye.